Anujan S talks on refinery technology, which include processes, process equipment, and also oil economics.
Welcome back to the presentations for the benefit of BTech students doing chemical engineering, and this particular episode is the 24th in the series, and this is on pressure control of distillation columns. The source of this material has been taken from the article by name Steady Under Pressure, written by Andrew Slowly. The first question which comes to one's mind is, why should we control pressure of a distillation column? The issue is very simple. When you design a distillation column, we assume constant pressure, and varying the pressure will change the relative volatility and will affect the fractionator of performance. And this will swing the column vapor loads and temperature profile like hell. Effective pressure control avoids spreading of the column and improves advanced process control, thus making running close to maximum capacity possible and more reliable. The pressure control methods can be categorized basically into two. One, by changing the mass flow rate, that's the vapor rate of control, and number two is the energy flow control. This includes varying the surface area, varying the heat flux, varying the surface area of the utility, varying the heat flux on the utility side. Controls can be classified under a different head, which is based upon the vapor flow. The first one is vapor flow is always present. Number two, vapor flow is always greater than zero, but in transient conditions it may go to negative. The third in this category is the flow zero steady state, but negative, it will go negative in transient conditions. Now we will discuss the case where the net gas flow is always zero and direct control of vapor product. The method is by varying net flow out of the overhead condenser. So the requirement is that the net flow of gas should always be there. Advantage is that it is simple and direct, but the only problem is that it is very slow acting when the vapor rate is low. The second case we consider is blanketing of vapor. This is applicable when the net vapor rate is sometimes zero, or sometimes you can have slightly a positive value. Here overhead receiver, you have got a split range control. When the vapor production is there, the gas will be sent out from here to downstream receiver. If the pressure is low, that is no gas is coming in, nitrogen will be opened up to pressurize the system. This method is for total condensers, but it employs a net vapor bypass, hot vapor bypass, and the technique involves varying the area for condensation in the condenser. When you open the bypass, the pressure inside the drum changes, and this will vary the level of the condensate in the condenser. So when the area is changed, the condensation varies and the pressure is altered. Pressure control with air-fin condenser at the top. Directly the pressure signal can alter the speed of the motor for the fan of the condenser, and this will vary the condensation and thus the pressure. It's a very simple mechanism. The requirement is there should be a net vapor always greater than zero. This method is very popular for pressure control in distillation columns with huge vapor flow rate. That means net vapor rate is always greater than zero, and downstream is at a higher pressure. So we have a turbine driven compressor which pushes out the gas from the overhead receiver, and the speed of the compressor is governed by the pressure in the overhead line. So as the pressure increases, the speed of the compressor goes up, compressing more gas and pushing it down. And when the pressure is low, from the discharge of the compressor, a recycle line spill back joins at the column top, and this will maintain the pressure. This is a small variant of the earlier model. Now, if there is a chance of pressure going up beyond the set limits, excessive gas coming up, apart from the normal pressure control, we have another pressure control which is set at a slightly higher pressure, which will leave the gas to probably flare. So we have a safety mechanism attached. It's a normal pressure control with a turbine speed. It's a split range control plus an added precaution of a relieving control valve. This schematic gives the pressure control of a vacuum column with the help of ejectors, and how the pressure is controlled is from the discharge of the last ejector, a gas stream is recycled back to the column to maintain the pressure. As a last word, I have indicated only less than 10 methods for pressure control in distillation column. If you go to the literature, you can see at least 50 methods available. So don't restrict your search to these 10 numbers which I have listed. There are definitely better methods available. Depending on the context of your application, the paper flow rate, the selection will undergo a change.
Before signing off, I have a few requests. If you like this video, please press the like button and also share this video with your friends so that they also can be benefited. If you have any comment on this video, please drop a line in the comment section just below this video so that I can try to incorporate in the future versions. Also do subscribe to my channel so that you get immediate notification whenever I upload similar videos in the future. Thank you.